9596 continues with polar coordinates. And just like in the parametric mode that we did on the first day, where we don't always recognize the equations and things, we can convert it into a form that we recognize. So we're going to be doing that again today. We start out with the ordered pairs, and then we'll move into the equations. So this first box of information, very similar to what we've been doing since chapter 4. If you have the triangle, this is your R, and you have X and Y. And so if somebody says, hey, what's the cosine of that angle? You do cosine of theta equals the adjacent X over the R. And if I just multiply by R on both sides, we get X equals R cosine of theta. So that's where we're going to be at. And so when we convert these first couple ones, we just use those two formulas. So I may refer back to this box of information up here. Tangent is still sine over cosine. And R squared equals X squared plus Y squared. That simply would be the Pythagorean theorem of that triangle. So to convert these, I just write down X equals R times cosine of theta, where R is 2 and theta is 4 pi over 3. And so you'd use your unit circle to help you out. Cosine of 4 pi over 3 will be negative 1/2, and we end up getting negative 1. And then I do the Y equals R sine of theta. R is 2 again, sine of 4 pi over 3. Now this time, the sine is root 3 over 2 negative. So 2 negative root 3 over 2. And the 2's will cancel out, and you're left with just the negative root 3. So my answer, this is R and theta. Now it's X and Y, and it's negative 1 comma negative root 3. Do the same thing for X equals 5 cosine of negative 7 pi over 6. And Y equals 5 sine of negative 7 pi over 6. So now cosine of 7 pi over 6 is the negative 210 is really what it is. So if you start at the right-hand side of your unit circle and you go backwards about 210, right, we're landing in the same spot as 150. So if you do the 150, you're in the second quadrant, so cosine will be negative root 3 over 2. And so that's just negative 5 root 3 over 2. And Y would be 1/2. So if you want to write that 5/2 or 2.5, that would be your answer. Now, if you could do polar graph paper and put it on top of a Cartesian coordinate or regular XY coordinate system, these dots should be in approximately the same location, right? So, now the last one, if you can do the same two formulas, but I would just show you. If I go to where pi over 2 is, that's at the top of the unit circle, and if we go out 1, 2, 3, 4, my dot lands right on the positive x-axis, or the positive y-axis, excuse me. And so I already know that my x is 0 and my y is 4. So go ahead and take a look at the example 2, the DIY. Try those, and then come back and look at the answer. All right, so let's go over and take a look at the answers for number 2 DIY. They're giving you the equations, or excuse me, the ordered pairs, and if you convert them, there should be your answers. Now this is an example of putting the numbers into the formula, the negative 2 pi. I might have just done negative 2 pi as my answer right here. This is the angle. And then I go over here, negative 3, put my dot, because the negative 3 sends me to the other side, and so negative 3, 0. So you don't have to use the formula, but it makes it pretty easy if you do. Okay, if we go the other direction, now we're converting from x and y to an r and a theta. So the first thing we'll do is we'll draw our xy axis. We're going to go right 3 and up 4. So if you do that, you put a dot there. Draw your line out from the origin, just like we did in chapter 4. Go vertically to the x-axis, and there's your triangle. So now we have to find r and theta. Well, r is pretty easy because that's the Pythagorean theorem. So r squared equals 3 squared plus 4 squared. So r will be the square root of 25. So r is 5. Now you have all 3 sides of the triangle. You certainly can use any trig function to find theta, but the given were my opposite and adjacent. So opposite and adjacent. So I'm going to do tangent. So tangent of theta equals opposite over adjacent. Inverse tangent on both sides. And theta will be, so let's go over to the calculator. I'm in degree mode, so I want my answers coming back to me in that degree mode. So that's good. And so now I can do second tangent, the inverse tangent of 4 divided by 3, and that's 53.13 degrees. So when you talk about converting this, you write down your r and then 53.13 degrees. So that's r and theta. I'm not sure if the video caught, but I went to the calculator. I made sure I was in degree mode. Then I typed in second tangent, the inverse tangent of 4/3. It gives me that 53.13. So there's your r and there's your theta. All right, so we're going to do the same thing. We're going to draw an xy axis. We're going to go to the left 5 and down 12, so that puts the dot in the third quadrant. Come out from the origin, go vertically back to the x-axis. So we went left 5, down 12. We need to find r and theta. So r will be the square root of negative 5 squared and negative 12 squared. So that's that's 25 and 144, which is 169, and the square root of 169 is 13. And then we will inverse tangent, so we'll do tangent opposite over adjacent. So when you do the inverse tangent on both sides, so again, go to the calculator, second tangent. They're both negative, so you can skip typing in both negatives. And I get 67, let's just call that 67.38, that's fine. But that's theta, like right here. I want to make sure we go all the way from 0 to here. So we have to add an additional 180 to that, so that's 247.38. So then the final answer is R13 theta 247.38. And again, this last one, if you draw a picture of it, don't go left or right, just go down 2. Well, in polar mode, I could call that 270 degrees, or 3 pi over 2, and the r is 2. So it's a distance of 2, and you can call it 270 degrees, and there are other representations that you could try writing down, but that's one of them. All right, so example number 4 is another DIY, so try drawing your triangles and come up with the polar coordinates. All right, so let's go over and look at the answers for the DIY. So the first one, again, you would be to the left 8, down 15, so you're over here. So you can do the Pythagorean theorem, you get 17, and again, 61.93 would be in the wrong quadrant, so you have to add the 180, because you want to always go from here to here and to there. This one puts us in the second quadrant, so you always want to draw the picture so you know that your angle is in that quadrant when you do this. So 3 root 2, 135, and then 4 comma 0, you could say 4 and 0 degrees, or you could say something like 4 and 2 pi, but that's good. All right, so now we're going to convert these equations into polar mode. So these should be things that we recognize. And if we just look at this one, this is our basic parabola from Algebra 2 even. It would just be a quadratic, which is a U-shaped graph opening up, has vertex at the 0. Now if I want to convert into polar mode, I can think of it in a couple ways. Like the y, if we think back to when we converted the coordinates, y is equal to r sine of theta. So I'm going to replace this y with that. Well, the same thing can happen with the x. X is r cosine of theta. But the x is being squared, so I need to square my r cosine. And now we're ready to solve this. We have r sine of theta. I'm going to go ahead and multiply this out. So the r and the cosine both get squared. Now when you're solving for a variable, they all have to be on one side of the equation. So I need to subtract the r squared cosine squared to the other side. And because they both have an r, I can factor it out. Leaves behind the sine of theta. One of the r's stays there. And so now I have two factors that I can set equal to 0. Well, setting r equal to 0 doesn't make sense. You can't have a circle with radius of 0. So we're just going to disregard that one. And so the one I'm going to solve is the sine of theta minus r cosine squared of theta equals 0. So I'm going to send the sine to the other side. So it goes over as a negative sine of theta. And then I'm going to divide by negative cosine squared. And so I'm left with r equals sine theta divided by cosine squared of theta. All right, so now when we go to check this, I think this is my r equation. So on the calculator, I have to go into mode, and I have to make sure that I'm in polar mode. And to type that in, I have to do the sine. Variable button is my theta. But when you go to type in cosine squared, you have to be careful. You have to do cosine first. So notice I have parentheses started, and I have to do another parenthesis. So that whole cosine gets squared, and when I hit graph, it should be the parabola opening up, and there it is. 0, 0, opening up. I feel really good about my answer. Okay. So this next one, again, if I graph it, if you take turns letting x be 0 and then let y be 0, you can find your two intercepts. So when x is 0, y would have to be 3. And when y is 0, x would have to be 4. And so we're kind of looking at, for that particular equation, it's linear. It's a straight line. So we kind of start with the same. We're going to go 3. Another name for x is r cosine of theta. And another name for y is r sine of theta. And again, both terms have an r, so I can just factor that out. And then I can just divide by everything in parentheses. So it ends up being r is 12 divided by 3 cosine of theta plus 4 sine of theta. Which is kind of a crazy equation, but when we go to our calculator, it should be that straight line. So clear that out. 12 divided by 3 cosine plus 4 sine. Technically close the bottom and hit graph. Hitting at 3. And not 4, so did I? There we go. So standard window, hitting at 3, 1, 2, 3, hits at 4. So we feel good about our answer. And this last one, if I looked at it, it's a circle that's to the right 2. So this means opposite, so we go to the right 2, 0 for the y, and that's r squared, so r would be 2, so that's a radius of 2. So that's the graph we should get. So the first thing I have to do is I'm going to FOIL that out. That's x squared minus 4x plus 4 plus y squared is equal to 4. Now if you go all the way back to the box, remember r squared is equal to x squared plus y squared. So this is x squared plus y squared. I'm going to replace that with r squared. Here is negative 4 r cosine of theta. So I'm going to replace that x with r cosine of theta. And when I subtract 4 on both sides, I'm left with this equation. So we have an r in both of them, and I can factor that out again. I still have one r there, just 4 cosine of theta here. And remember, setting these two equal to 0, this won't make sense to have an r equal to 0. So all I have to do is solve this one, and I just add the 4 sine to the other, or 4 cosine to the other side. So that should be my answer. So again, if I go over here and go to y equals, and I do 4 cosine of the theta. Now that looks a little elliptical, but if you look, my tick marks aren't the same size because of our widescreen. So if that bothers you, go zoom 5, which is to square the window. Now all the tick marks are the same. We just have more along the x-axis. So nice circle, shift to the right. So it worked. I'm going to go back to my standard window. Okay. Now we're going to go the other direction. So we want to get rid of the r's and the thetas and get to this polar mode. Now there are two things you want to remember. One, how can I get r squared? One, I can square both sides of the equation. So whatever's on both sides, I can square it, and that creates an r squared. Or two, multiply by r on both sides. So this first example, I can square both sides, and I get r squared is equal to 4. And r squared can be replaced with x squared plus y squared. So there's a nice x and y equation, what we call rectangular equation, because I know that that's a circle with the center at 0, 0, radius of 2. And what we could have done in the beginning is just done the graph. What is y equals 2? Oh. What is the graph y equals 2? And it's just a circle. And again, if you want to see more of a circle, hit zoom 5 to square it. So that's what we ended up with. All right, so on this example, I'm not going to square both sides. I'm going to multiply both sides by r. And what I end up with is r squared equals. And when you multiply, let's put the r in the middle so you can see it easier. So now I can replace the r squared with an x squared plus y squared. And the r sign can be replaced with a 4y. And basically now we're ready to do all the completing the square like we did back in chapter 9. So I would have x squared plus y squared minus 4y. I can add a new number, a 0 over there. So you take your negative 4, divide by 2 is negative 2, put it in parentheses is 4. So I can add 4 there and add 4 there. And now I have x squared plus y minus 2 squared is equal to 4. And I know that that's a circle shifted up 2 with the radius of 2. So it would look something like that. So now let's go back to the calculator and just double check that that's what the original equation was. So 4 sine of theta. And we have that circle shifted up just like we have over here. So I'm getting rid of r's and theta. So the first time I squared both sides to create the r squared. The second time I multiplied by r. All right. So in this example, I'm just going to multiply by the sine squared on both sides. So I have r sine squared of theta is equal to cosine of theta. And I have that r sitting there, and I need to get rid of it, so I need to create an r squared somehow. And again, multiplying by r will be probably the nicest. So I have r squared sine squared of theta is equal to r cosine of theta. And we're going to go ahead and write this as r sine of theta squared equals r cosine of theta. So now this is y squared, and this becomes x, which, according to what we did in 9.1 to 9.3, would be a parabola tipped on its side, vertex at 0, 0, and opening to the right. So let's go back to the calculator one more time and type that in. Cosine of theta cosine of theta divided by sine squared. So again, you have to do parentheses first, then type in your sine of theta, close it, square it, and there's your parabola tipped on its side. All right, example 3 has 4 DIYs, so go ahead and take a look at those, and then we'll come back and look at the answers. All right, so let's go over and take a look at the answer. This one is a circle, 0, 0 for your center, radius of 4. So if you replace that with r squared, you can take the square root of both sides. Now, normally you should get a plus or minus, but it does make sense to have an r of -4. So that's just r is 4. So that one works. If you replace the y with an r sine of theta, just divide that over. So this is a horizontal line. Should just be a horizontal line at 2. Type that in and you're going to get the same thing. All right, so this one produces a vertical line. So you can type that into polar mode and see that. Now, when you multiply both sides by cosine, you get r cosine of theta. That replaces with the x, and you just have x is -9. So the nice vertical line going up and down. And the last one, you can square both sides, but that's going to kind of mess this up. So we're going to multiply everything by r. So you get r squared, -3r cosine of theta. Replace the r squared with x squared and y squared. R cosine is the x. And then you need to complete the square. And when you complete the square, this will be your final answer. So a circle, left 1.5, not up or down. And if you square root this, you get 3 halves. So you have a radius of 1.5.